So here we're going to look at program design for endurance training. So earlier in the semester, we talked about just general aerobic training adaptations. This discussion is going to it's still going to talk about some exercise physiology, but we're going to look more specifically at how we kind of deal with endurance training. And some of this will look at just both the aerobics from the standpoint of a true endurance athlete. So endurance athletes, you're looking at your middle to long distance runners, or really your classic endurance athletes. Your team sport athletes that we have, like for instance, like soccer players are not, for instance, endurance athletes. Do they need an aerobic requirement? Certainly, to help them recover between repeat sprint bouts. But like soccer players, field hockey players, they're not endurance athletes. Even though their sport lasts a certain amount of time, they're not endurance athletes. Endurance athletes are those that have to, again, kind of compete at longer distances, where it's a little bit more classic, that endurance training need. But again, some of these things will kind of still apply to, the non-endurance athletes who need repeat sprint ability in order to allow them to recover. So factors related to aerobic endurance performance, and again, this kind of harkens back to, again, a lot of the, again, exercise physiology principles. So maximal aerobic capacity, so as the duration of an aerobic endurance event increases, so this, kind of makes sense, so does the proportion of the total energy that must be met by aerobic metabolism. So basically, the longer the event, the more the aerobic capacity becomes important. So again, the fuel sources needed in order to kind of endure whatever it is, the activity that they're doing, they need more aerobic metabolism, so there's more from that energy system that's going to occur. One of the things you need to consider is the lactate threshold. So there's actually several studies that show that lactate threshold is actually a better indicator of aerobic performance than VO2 max. So everybody kind of looks at VO2 max, and VO2 max has an importance. So VO2 max is how much oxygen the individual the actual oxygen uptake that's occurring. And it's a marker of their ability, but sometimes there's the tendency to overuse it. So lactate threshold is the speed of movement, or the percentage at VO2 max at which the blood lactate concentration is observed, or the point at which blood lactate concentration begins to increase. So that's the point where lactate basically starts to develop. So in other words, when someone's even doing like a long distance event, okay, their lactate, they're going to build lactate even though it's an aerobic event, but their body's able to oxidize, metabolize the lactate to be able to use it. The point at which the buildup doesn't equal clearance or exceeds their ability to clear the lactate, that's when they've exceeded their lactate threshold. So that's actually a better indicator of performance, more so than just the VO2 max. Because what that also tells you a lot of times about the athletes is what their actual aerobic ability is at the muscular level, which again is a little bit better of an indicator of performance than just looking at, how much oxygen they uptake per minute. Exercise economy is another important thing too. So it's a measure of the energy cost at a given exercise velocity. So this just basically looks at how efficient are they at kind of using their aerobic metabolism. And again, some little things actually contribute to this. So again, if they improve this, they actually enhance both their VO2 max and their lactate threshold. So again, this looks at things like how efficient their movement ability is. Okay, so when we look at like their strength and how their mechanics work with whatever exercise they're doing, the more efficient that is, the better off they are. So just for instance, looking at something like looking at running gait, for instance. So if their running gait isn't as efficient, their exercise economy is not going to be as good. So little things like that will contribute to their ability to use their energy sources and again increase that efficiency for the movement that they're carrying out. So when we're looking at designing an aerobic endurance program, like with all other programming, there's things you have to consider. So you have to look at the exercise mode. So the exercise mode just looks at what type of exercise are they actually doing. So, are they cycling? Are they running? Are they swimming? The important thing to remember is you want to try to do as much specificity towards what it is the athlete's actually going to do. In other words, if they're a distance swimmer, so if they do one of the longer swimming events, most of their aerobic conditioning then should be done with swimming, okay? Does that mean they can't cross train or use other modes? No, and you actually do want to do that because you want to, again, prevent, injuries, and you want to be able to deload them a little bit. But for the most part, you want the bulk of their actual what they're actually doing to replicate what they're going to do within their specific sport. In other words, if they're a runner, you can't put them on an exercise bike for a prolonged period of time to work their aerobic ability because it's not going to carry over again. That's where, the muscles and what they have to do, they have to be able to have a certain degree of aerobic ability at the muscular level related to their actual activity. Training frequency. So again, that just looks at how many times per week we're going to be doing these, that they're going to be doing their aerobic endurance training, and we'll talk about how many times a week we should be looking to do this. This is going to be primarily dependent upon intensity and duration. Okay, so intensity and duration is going to dictate how many times a week, plus also where they're at within their training cycle. Okay, so again, where they're at within their training cycle. Are they in the off season, preseason, and again also on intensity and duration of their the exercise, and then intensity. Okay, so again, the adaptations in the body are specific to the intensity of the training session. So for instance, high intensity aerobic exercise is going to increase, again, cardiovascular, respiratory function, allow for oxygen to be delivered to the working muscles. And again, increasing exercise intensity. So this is something that's important to note even for endurance athletes, because endurance athletes have a tendency to do a lot of low intensity things. Again, you want to make sure that the intensity is high enough, and at some point you're kind of working that aspect of training. So that's going to be something important to note. We're going to talk about how we could kind of regulate training intensity. One of the ways we regulate intensity with these classical conditioning parts of training is through heart rate. Okay, and you can see I have a little chart here. Actually, this chart's going to be a little more relevant to some of the things we're going to be talking about on the upcoming slides, because we're going to talk about how to use different measures of heart rate relative to percentage of VO2 max, and how we could kind of utilize that as a way to monitor exercise intensity. Because when you're talking conditioning and aerobic abilities, the heart rate's probably the easiest way to do that, and it's actually pretty inexpensive to do it. Now, there are other ways to do it, but heart rate's probably one of the simpler ways, and you can simply do that just with a heart rate monitor, which again, basic heart rate monitors don't cost a lot of money, so they can be an inexpensive way to kind of regulate that. So there's a couple different ways we could look at heart rate. So one of them is through target. Again, we talk about target heart rate calculation. So the Karvonen method is the most common way to do that. So basically the way you do that is you get your age predicted maximum heart rate. So age predicted maximum heart rate is just 220 minus your age. Okay. Now, if again, as you start to learn more and you get into research, age predicted maximum heart rate could be a little deceiving sometimes. So it's a good starting point. But the one thing you have to realize is, this is just kind of an aside for practical purposes, as individuals get better trained, the age predicted max heart rate doesn't tend to be as accurate, because you'll see that people who are trained really well and are consistent with their exercise, their maximum heart rate can actually be higher than this sometimes. Okay, so that's just something important to note on the side. But as a starting point, it kind of gives you an idea And as long as you're being consistent with it, it could kind of give you an idea of where they need to be at for their training. So again, to get back to this, so now to find your heart rate reserve, what you're going to do is you're going to take that age predicted max heart rate and subtract their resting heart rate from that. So you want to find the resting heart rate. Simple way to do that is just, go up to the neck, take their resting heart rate. The easiest way to do that is just take the pulse for 15 seconds, multiply that by 4. That's their resting heart rate. Then you find their target heart rate. So the target heart rate is just going to be the heart rate reserve times the exercise intensity, so whatever percentage you want it to be at. And then you'll just add the resting heart rate back to that. And again, do that calculation twice, because what that does is give you a range. It's always a good idea to sort of give a little bit of a range to have the athlete work towards. So say, you want them between 60 and 70%. Just use 60% for the first calculation for exercise intensity, use 70% for the second, and then that gives you a target heart rate range. Now, the second way to do it is just use percentage of maximal heart rate. This one's a little simpler, but it's not quite as accurate, or it doesn't give you quite the same. If you look at the chart, and the chart's in your book as well, that chart that I have on the slide looking at the percentage of VO2 to heart rate reserve versus maximal heart rate, it doesn't quite line up as readily with the percentage of VO2 max when you're just looking at intensity of exercise. But it still has the same increase as does the VO2 max. So it's still a way to do it. Again, however you do it, just be consistent with it for practical purposes. But with this one, all you're basically doing is finding the age predicted max heart rate, and then you're just multiplying that by the exercise intensity. So you remove a step with this one, but it doesn't have the same relationship that the Karvonen method does, okay? Again, either one of them are fine to use, again, just to give yourself a reference point. But, when you're working with athletes long-term and stuff like that, or you're working with athletes of different abilities, you may just have to be cognizant of, some slight, I guess, inaccuracies that you might run into. And again, that's something that you'll kind of see as you get experience with stuff. It's not something you necessarily have to be concerned with now. I'm just kind of painting a full picture of this for you. So again, you have the heart rate reserve versus the percentage of maximal heart rate method. Again, this one just removes one of those steps. Now, ratings of perceived exertion. So this is something that you could utilize. Now, this has to be used in a little bit more of a controlled setting. So what you'll actually do here is, so you can use this to regulate aerobic endurance training. So literally what this is, so if say someone was on a treadmill, they do this a lot in studies when they're doing what they call rating of perceived exertion. So what the person does is they just rate their exertion based upon a scale. So here you have a 1 to 10 rating. So literally if there was an athlete on a treadmill and we were trying to monitor their intensity, what you do is you'd have them run at a certain speed. And in many instances, what they do in studies is they'll literally have this chart up, and they'll look at the chart, and during their exercise, they'll say, well, where do you rate your exercise intensity now? If they say, well, I rated a 5, well, then they're going at moderate intensity. And a lot of these scales, it sounds like a pretty simple thing, but a lot of them have been sort of justified through research. Now, the one thing to note with rating of perceived exertion scales is, and I have this on here, is they may be influenced by external environmental factors. So what that means is, again, their perceived exertion, if you think about your own experience, if you're outside running and it's 90 degrees with high humidity versus running when it's 70 degrees out with a slight breeze, your perceived exertion is going to be different. In other words, you're going to obviously feel like you're training harder, or the intensity is harder when it's 90 degrees out with the high humidity. So that's what they're saying here. So some of this could be influenced by external environmental factors. A lot of times this gets used in research and stuff like that, and obviously that can be controlled, because if they're indoors doing something, you could, there's climate control that you can kind of of over C. But that's something to note with these perceived exertion scales. I've actually kind of used this informally with a lot of my early off-season aerobic training. So a lot of my early off-season aerobic training that I've done for athletes when they're just getting out of their season, a lot of times I have them just go at like moderate to easy pace. And the way I've always done it, I've never used exertional scales per se, but what I would tell the athletes is if I walk up to you and want to have a conversation with you while you're on the treadmill, you should be able to have a conversation with me, but you should be right at that point where as you go any harder, you wouldn't be able to. So in other words, you should be able to talk to me while you're still running. That was one way I always kind of did it, as opposed to, trying to give them scales. And the athletes always seemed to be able to work with that. They didn't seem to have a problem. But that's kind of I guess, an informal way that you can, sort of do this as well. Metabolic equivalence is another way that you can regulate intensity. So what a metabolic equivalent is, so one metabolic equivalent is equal to 3.5 milliliters per kilogram per minute of oxygen consumption. And what that is that's considered the amount of oxygen required by the body at rest. So you can actually know, and many people actually use this to calculate like calories when people are looking at diet and weight loss. This is one thing that people actually use. So literally when you're at rest, you're at one metabolic equivalent. So if you're just sitting watching television, you're at one met. If you go for a 20-minute low intensity walk, and there's actually studies, there's books and stuff where if you want to look at how many metabolic equivalents different activities are, you can look this up. But for instance, if you were to get up and go for a 20-minute low-intensity casual walk, that might be considered 4 metabolic equivalents, okay? If you go for a run, that might be considered 6 metabolic equivalents. So that's another way you can look at exercise intensity, and there's actual, there's books and resources where if you just wanted to look up, well, how many metabolic equivalents is this activity, you can actually see that. There's full books and stuff that are kind of dedicated to that. So again, it's another way to monitor exercise intensity. Probably the most common way I've seen this used, this method used, is actually related to dietary purposes. But again, you could also do this with just kind of regulating intensity in general. Power measurements are another thing. Cyclists use this a lot of times on their bikes. So in other words, they'll actually use power measuring cranks and hubs to regulate the intensity that they're doing. And again, metabolic rates closely related to mechanical power production. So what you'll actually see is many times you'll see cyclists use these bikes that, kind of change the resistance of what it is they're doing, and sometimes their equipment is sophisticated enough they could actually get power measurement readings, and that kind of tells you what their intensity at which they're doing something is. So this usually requires some sort of instrumentation to use, and again, the duration of exercise of a session is influenced by intensity. So in other words, the higher the intensity, the more power output, that's going to decrease the duration. So there's that inverse relationship that you're going to see between exercise duration and exercise intensity. As the duration goes up, the intensity is going to have to come down. So that's something that's going to be important when you're looking at, again, kind of monitoring your training sessions. So exercise duration, so again, this gets us back into the different types or different components. So this is the length of the actual training session. So again, that's going to be inversely proportional, as we said, to the intensity. So as the intensity goes down, the duration should go up, and vice versa. So that's going to be important to look at. When we look at exercise progression, so the progression looks at how we're increasing frequency, intensity, and duration. So any one of those variables, be it frequency, intensity, duration, and again, you can't raise all 3 of them. So usually you're going to pick 1, maybe 2, okay? But even when you start to raise 2, it can get a little dicey sometimes, and you can risk overtraining. any of these should not be increased more than 10% each week. Okay, so for instance, say you're going to increase your duration of exercise. Well, you're only going to increase it by at maximum each week 10%. You can't have any sharp increases in any of them, because that's where you're going to start to see things like overtraining and overuse injuries. So it's important that you don't increase anything too sharply or increase too much at one time. Typically, you're only going to increase one variable. Okay. If you start to increase more than one, you could run into a situation where you overtrain. So that's something you'll want to do. So, and sometimes based upon your programming or what they need, you may only be able to manipulate one of them. So in other words, it might not be feasible to increase their frequency or duration. Like frequency and duration tends to be the two of the harder things to increase, because again, they're usually going to be, for instance, with frequency, sometimes you might not be able to do more than twice a week for this type of training, because they're going to have other things that they have to train. Like endurance athletes, for instance, still have to do strength training and everything, and speed work. Now their speed work will be different than what a sprinter would do, but they still have to do speed work. So, intensity might be the thing you have to manipulate the most, because again, the frequency and duration aspect could get pretty difficult. But again, just monitor any one of these that you do. Again, only 10% at maximum. That doesn't mean you have to increase it 10% each week, but that's what you would want to hold it to. So looking at types of endurance training programs, so these are all discussed in your book as well. So long, slow distance is what we classically think of as aerobic endurance training. And the one thing I want to emphasize here with aerobic training, you don't have to only do long, slow distance training. Like this is the classic thing. You say, well, they're going to train them for aerobic. Will they run for 20 minutes or they bike for 20 minutes? You don't have to do that. And again, this type of training for your team sport athletes is actually not very beneficial to them. So, you can still train them aerobically, but you want to make sure you're training them aerobically in a way that's going to enhance their speed properties. This isn't going to do this. Your long, slow distance training is most appropriate for, again, your more distance duration type runners. So again, this is training at distance greater than race distance, typically for 30 minutes to 2 hours. The intensity is going to be around 70% of your VO2 max. Your adaptation to this. So the adaptations is this is going to enhance the body's ability to clear lactate. And it's going to cause a shift of the type 2X fibers to type 1. So if you remember our fiber typing, or if you're if you're a little rusty on that, just go back and review that. But that's where you're going to get your shift. So if you think about it, for again, athletes like soccer players and field hockey players, that yes, their competitions are 35 minutes, 45 minutes and longer, but remember, that's done in interval fashion. So they're not running at one pace for that entire time. So you can see if they do too much of this type of running, how that might inhibit some of the other qualities that they need. So the intensity is going to be lower than competition. And again, this is where it could be a disadvantage if too much of this is done. So and I would even say that for distance runners, if they do too much low intensity distance running, again, for a distance runner, the winner of the race is still the person who runs it the fastest. So if they're doing too much low intensity running, it's going to inhibit their speed. Okay, so it's important to kind of note that you want to make sure that they're still doing enough other type. I always said, like, even, cross country runners, if you look at classic cross country distances in high school and college, they don't do enough high intensity running. Now, again, high intensity running is different from them versus other athletes, but you can still program it in. Pace and tempo training, okay, and the difference here is, so, steady pace is going to be more, is going to be training at one speed for a prolonged period of time, whereas tempo is going to be more interval fashion. So again, here you're looking at, in general, for both of them, the intensity is going to be at or slightly above competition intensity, and it's going to correspond with the lactate threshold. With intermittent pace, or what we would call tempo, that's where you're going to do series of shorter intervals with brief recovery periods. So that's going to enable the athlete to actually go at an even slightly higher intensity. So in other words, steady pace, you're going at steady pace. You're going 20 to 30 minutes and it's continuous, whereas your intermittent pace or tempo is going to have intervals, okay? Where you can now maybe within the work intervals work at a slightly higher intensity because now you're getting recovery periods. The objectives of this, or what you're looking to get out of it, is you're looking to develop a sense of race pace and enhance the body's ability to sustain it, okay? This is also going to help improve running economy, and it's going to increase the lactate threshold. So here we're raising the intensity beyond just long, slow distance training, which again is an important variable to look at even with endurance distance runners. So now we're going to bump the intensity up even higher to pure interval training, okay? Now, the interval training we're talking about here is more as it relates to aerobic endurance. So interval training can involve some slightly different variables when you're looking at other types of athletes. This is strictly just looking at aerobic based. So exercise at an intensity close to VO2 max for intervals of 3 to 5 minutes. Work to rest ratio would be 1:1. Now, again, this is specifically for aerobics. If you were looking at the other energy systems, your work intervals, the timing of them would be different along with the work to rest ratios. This allows athletes to train again. Now you're getting higher intensities, so this is still important, okay? Again, even a marathon runner, which is really long distance, they still have to train at intensity at some point, okay? So even in a marathon, even though it's a longer race, okay, the winner of the race is still the person who finishes it in the fastest time, and that's the variable a lot of people tend to ignore. So this is going to increase VO2 max and enhance anaerobic metabolism, which again, anaerobic metabolism is still going to have to work even in endurance events. Again, this should be used sparingly. You have to remember, so this is considered high intensity training. So the recovery from high intensity training day to day is going to be longer. You can't recover from high intensity training within 24 hours. And they should have a firm aerobic endurance training base when they're doing this. So again, continuing along the spectrum here, now we have high intensity interval training. So this is repeated bouts interspersed with brief recovery periods. Athletes need to spend several minutes above 90% of their VO2 max to do this. So again, we're taking this another step further as far as the intensity continuum goes. Again, this is effective for improving running economy and running speed. Again, that running economy piece is important. Can they keep their same biomechanical efficiency with faster speed? So in other words, if sometimes you watch people when they run and they get tired, what starts to happen? They start to break down in form, and then that's going to further cause them to, utilize even more energy in order to continue running. So here's an example of a long interval hit. So, greater than or equal to 2 to 3 minutes at 90% of their VO2 max with a brief recovery bout. So again, this is something you can use, but you got to kind of use it sparingly. You got to be careful with how you program this. It's an important part of programming, but you're not going to be able to recover from this in 24 hours or less. This is going to require at least a 48-hour recovery window. And then fartlek training. So what fartlek training does is it combines other methods of training. So for instance, what it does is it looks at easy running combined with hills or short, fast bursts. Again, this type of training could also be modified to work on other aspects of energy system, but for the sake of our discussion here, we're just looking at aerobics. It can be adapted for cycling or swimming. So in other words, with cycling, an individual, if they're going out on their bike, they can use the gears on the bike to do this. So they could change the gears to make it harder to pedal, easier to pedal, and use that as a part of their intervals. With swimming, you could use different swim strokes. or you could use resisted things within a pool. So in other words, there's different types of resistance implements you can use within a pool to kind of change the intensity over time. So it's basically, when you look at fartlek training, it's basically interval training, but it's interval training with also using other means to change the exercise. So it's not simply just work recovery periods. Really, for classic fartlek training, what you should be doing is also using, for instance, with running, you should be incorporating hills or different ways to change the resistance when you're doing it. Again, the benefits of this: enhanced VO2 max, increase lactate threshold, and improve running economy and fuel utilization. So with each one of these types, make sure that you're able to tell me what benefits they're going to get out of it. In other words, what are the physiologic adaptations that can be utilized in order to assist with their training. So now the applications of this, when we look at the different training seasons, so off season or base training, again, begin with long duration, low intensity. So even for, again, not, applying aerobic stuff to the non-endurance athlete, again, your team sport athletes, I usually start with a more low intensity conditioning anyway. They're coming off of their season. Their bodies aren't recovered to do a lot of high intensity stuff. They may do even some, even some closer to steady pace type training or long, slow distance stuff very early on, but that would be the only time they would really be able to do that is early in the off season, but that's their base season. Pre-season, focus on increasing intensity, maintaining or reducing duration, and incorporating all types of training. And you'll gradually, even in the off season, start to increase intensity. In other words, your whole off season isn't going to be long duration, low intensity. You do want to gradually increase that intensity because you don't want sharp increases even between the seasons. In season, again, you're going to be basing it around their competition. So you're going to want to just, again, there's so many variables with this with a lot of different athletes, and we get into this in some of the other classes. In season, you're going to look at, when are their competitions? First of all, what type of competition are they in? So, what is the distance of their races? And that's where you'll kind of modify that. Really, from a general physical perspective, they should be at where they need to be at. You're not going to increase a whole lot of their, physical fitness base per se during the competition phase because that should have all been done in the off season and preseason. And then post-season active rest, this is where we're going to focus on the recovering. So it's important to look at that. Again, a lot of times athletes will have, injuries they may have to recover with. So that's going to be all things you're going to need to kind of consider when you're looking at, how you're going to kind of modify their training into the post-season. But it's going to be active rest. Sometimes they may do like a complete week or two where they don't do anything. Again, it just kind of depends upon what they've kind of dealt with over the course of their season. So some special issues related to aerobic endurance training. I talked a little bit about cross training at the beginning. So this is where you're going to use a mode of training to kind of maintain their general conditioning, but it's not going to be specific to what they do. So for instance, a runner may ride a bike, or they may swim, or a swimmer may come out of the pool and do what we'll call dry land conditioning. And this is good because they can improve their general aerobic qualities, and it can also help them, reduce their chances of injury. So in other words, if all somebody does is swim, even if their swimming form is good, there's the chance to develop muscle imbalances and things like that. So some cross training can be a benefit to everybody. This would be something that would be primarily reserved for like off-season times, or if they do have an injury and they have to work around something. Detraining. So detraining occurs when an athlete reduces training duration or intensity or stops training altogether. Sometimes that may just have to happen because of an injury or illness. However, even during injury, it's a good way to try to find some way to at least maintain some level of conditioning. Sometimes with illness, you can't avoid that. For instance, if someone gets like the flu or something like that, they have to stop training. There's nothing they could do to maintain. but they're going to experience a loss of physical adaptation. So it's important to note that if for some reason they did detrain, that's going to change your long-term programming. So it's something that you want to be mindful of. Now, tapering is when you have a systematic reduction in training duration and or intensity. So with this, with tapering is something you're going to do as a part of their training. So it's basically a planned deload. So it's where you're starting to reduce their training duration and or their intensity, because what you're looking to do is peak them. So a lot of times what you'll do with athletes is you'll look to have them physically peak, but you want them to physically peak training-wise a few weeks away from important competitions, so that then they could kind of deload a little bit and then kind of be able to hit a high performance element. So that's actually something that you do want to do. That's, again, you have to plan to reduce volume, reduce intensity in order to do that. And here's a big thing and I'm talking about this related to endurance athletes, is resistance training. So your marathon runners and your cross country runners, they tend to neglect strength training, and that comes at their peril, because again, there's benefits from resistance training, and I'm not just talking high rep resistance training. That's the other mistake a lot of endurance athletes tend to make, is they think, well, I'm going to do everything for 20 reps or 30 reps. Number one, that doesn't usually even relate to the endurance that they do. 20 reps of a leg exercise isn't even close to what you have to do endurance-wise when you're talking a lot of your long-distance races. But improving strength and actually working at like low repetition schemes is beneficial. This can improve their ability to withstand injuries. And again, force production is still important, even for a marathon runner. Again, the fastest person wins the race. So there's still a force requirement related there to every time their foot strikes the ground. So, it could also help with their ability to finish a race fast. So this is something really important from an injury prevention perspective. For distance runners, you don't have to worry about accumulating muscle mass, because again, with what they're going to do with their training, their body's not going to adapt in that way anyway. So, a lot of times that's the problem with endurance athletes. They think, oh, I'm going to gain all this muscle and it's going to slow me down. The other specific training that they're doing their body's not going to adapt in that fashion. So that's not a fear that you have to worry about. We're actually talking about that in the advanced training class where we discuss how, for instance, a marathon runner isn't going to all of a sudden turn into this, big muscle-bound person just because they're lifting weights. They're still going and doing all of their running. So their overall adaptation, their body's not going to change based upon, well, I'm doing heavy resistance training, I'm going to grow all this muscle tissue. Their body's going to metabolize that when they go out for their run. So yes, if they stopped doing runs and all they did was lift weights, yeah, they would gain muscle mass, but chances are they're not going to do that. So their body adaptations are still going to be that, and they'll still get the benefit of the actual resistance training work. So the bottom line is they need to lift weights and they still need to improve strength. Another important thing to note is altitude, and the reason why is obviously the the barometric pressure and everything will change, and it will change the oxygen concentration. So the height of above sea level is ranging between greater than 500 to greater than 5,500 meters, and what that's going to do is it's going to decrease the partial pressure of oxygen in the air. So, now for individuals who live at altitude, this isn't a problem. Their body already naturally adapts to it. But say you're an athlete and you're traveling somewhere where the altitude is very high, you see this in certain parts, even within the United States. It takes a few days at altitude to adapt to that. So, you see this a lot of times, it's well known, for instance, going into Denver, Colorado, for the football teams, it's a home field advantage, for instance, for the Broncos, because they play at that altitude. Athletes will talk about how they go and play there and how they notice that they're maybe a little bit more winded after doing something, and part of that is because of the altitude. So now for those sports, it's a little harder to do the acclimatization, but for others, if you have the ability to do it, it takes about 12 to 14 days at altitudes up to 2,300 meters. But it can also take longer, so it's important to note. Okay. Now, if you're going to do it for an ergogenic effect, so in other words, some athletes will train at altitude just to kind of assist, not necessarily because they're going somewhere, but just to get the adaptation. In order to see an ergogenic effect, they need a very high dose. So it's a little hard to kind of get that. But, again, this is just something important to note, that if an athlete, say a lot of times like Olympic athletes, if they know, if the Olympics is being held somewhere where there's high altitude, they're going to try to do specific training at altitude, because if they never do it when they go to actually compete, it's going to impact their performance. They're not going to have the partial pressure of oxygen is going to be different, and their body's not going to metabolize it in the same fashion. So these are our learning objectives or chapter objectives. So again, there is stuff that can be applied here too. Again, we could change some certain things as it relates to team sport and field sport athletes, but the primary objective here was to discuss it as it relates to endurance athletes.